Hi guys. So sorry I'm late. I was doing a huge problem in pre-cal and my students didn't say anything to me and I'm like, oh my gosh, we gotta go. I kept them over. So anyhow, good morning. All right. All right, you guys. We're planning on taking an exam on Friday morning at 8 o'clock on 2122. If you have any questions, you want to make sure and ask me, but I am teaching a new lesson today. Okay, so this next lesson, I can't even teach until I go over factoring. I have to go over a bunch of Algebra 1 things before we can even start 3-1. So today I was planning on talking about factoring, which is a prerequisite for 3-1. But we're going to see how things go. All right. So are you guys okay with lesson 2122?
Ms. Birch, I've just had some quick questions about the calculator.
Yeah.
I saw some problems that had absolute value and parentheses, and I wasn't sure how to write them.
Yeah. Now, when you use the absolute value key on the calculator, what it does is this. And it expects an in parentheses. Now, there might be another set of parentheses inside. So you just have to make sure that the number of left parentheses, which in this case is 3, match the right parentheses 3. Because if you leave one off, you're going to get an error.
So that means that for some problems, we'd have to put double parentheses, right?
Yes.
Okay.
Yeah. And like I said, if you leave off a parenthesis, it will give you an error because they're not matched up. Is that what you're asking me?
Yeah.
Okay. All right. Anybody want to ask me about anything else? Are you guys good to go? Well, let me say this. I'm going to try real hard not to give you the hardest problems in the world. Okay, so right now, in my opinion, I am not testing you on fractions, even though I need you to know how to do them. So I will be giving you, a few, but I'm going to try to avoid them, with every single problem. So I need you to get more comfortable with fractions. We can't run away from them any longer. But I also don't want every problem to be a fraction. That's ridiculous. And so I'm going to really try to watch it. And I really just want to test your basic knowledge. Okay. And there's a lot of you that are kind of discouraged. You're scared about this class. And I don't want you to be. It's going to be okay. Let me tell you, as the math gets harder, it's going to get easier because right now is the worst time because you haven't seen a lot of this stuff. But a lot of it is going to be repetitive. So if you're getting a handle on this thing now, doing things later, like the next section, we're going to go into square roots. Well, if you know how to do a transformation on a quadratic, you're going to be good in some parts. If you know how to do a transformation on absolute value, you're going to be good in some parts. If you're doing really well at writing the equations given a graph, same thing. So you just need to hang in there. I have a lot of people right now that are wanting to, there's a couple students, they want to drop the class. And I'm like, make sure you tell the students that they may not be able to go to honors pre-cal if you don't have this class. So we have to make sure that you guys have the rigor to be able to go on. Okay, so you need to just understand that I never said this was going to be easy. So you just need to put your seatbelt on and you need to just stick with it. I'm here for you if you need me. Remember, you can contact me if you need to work through something. And let me just tell you the other thing. A lot of times students that are confused thinks that it'll take me a half an hour to clear up something, and it usually takes me 5 minutes. So a lot of times students will say, is that it? Is that all? You know, so the moral of the story is you got to give me the opportunity to talk with you. I don't want you sitting at home for hours and hours and hours trying to figure things out when I can clear up something in 5 minutes. But you have to give me the opportunity to do that. All right. And this is a very difficult situation because you and I can't establish a relationship, a rapport. You don't really know me that well because we're not in the classroom. You know each other that well. That part is like very, very bad and difficult. And so we just have to try to warm up to each other as much as possible in this very, very difficult situation. Okay? All right. So you just got to hang in there. Do not give up. See, the easy thing to do is give up. Everybody can give up. What you need to do is just keep working hard and press forward and just keep improving, keep improving, keep improving, keep asking questions. All right, that's my pep talk for today. Hard things are not an insult of your intelligence. Let me assure you, you're still intelligent. You are as smart as what we all thought you were. It's just you're being challenged like never before. That's okay. That's okay. You're being challenged. Okay. You're being challenged. Good. All right. Before I go into factoring, and I don't know what you guys know about factoring, but do any of you want to ask me anything about 2122? Okay, well, you have what it takes to if you need help, let me know. Okay, I need some feedback right now. Do you guys remember factoring? I don't know if you had it or not, from Algebra 1.
I kind of remember the idea of it, but it would be good to have like a refresher.
Yeah,
I agree.
okay, you see this right here? These are 7 factoring methods. And sometimes in Algebra 1, teachers only teach 2 of them. Well, you have to know all 7. So you have to have a repertoire of factoring problems. And so what I did is I put this under materials in Google Classroom. And what I assigned was 7 factoring puzzles. And you can probably guess each puzzle is one of the factoring methods. So this is a very, very important assignment that you do because it's going to be a practice of all the factoring methods. Now, like I said, I am not even talking about Module 3.1 now. This is a prerequisite for 3.1. Okay? So what I'm going to do is I'm going to start teaching the factoring methods and you let me know if you know them or not. Okay? Because if you know them, there's no point teaching them. The first factoring method is the one that you always want to do first. So this is always the one you try first. And it's called the greatest common factor. Also known as the GCF. And with this method, you can have any number of terms. So for example, if you had 3x squared plus 12, I call this the cake method. Now, I don't know if somebody stole this from me or if I learned it on my own or I got it from somebody else, but this goes along with prime factorization, which a student taught me. So if you build an upside down cake, we're going to take out a number and or variable. It's common in this expression. So what's common here?
3.
3.
So watch, we're going to do division, but we're going to multiply. Here we go. 3 times, let's say 3 goes into. We're going to say 3 times what is 3x squared? 3 times what is 12? And what you just did is the distributive property backwards. Now, in a little while, I'm going to tell you why we're doing this. If you're wondering, why are we doing this? This is stupid. Why are we going backwards now? Let's do another problem. That's a quadratic trinomial. If we want to do a piece of what is common in all 3 terms, we're going to build a big upside down cake.
Would it be 2?
Yep. So 2 times what is 14x squared? 7x squared.
7x squared. And then it's 8, negative 8x. And then it's 12.
Good. Okay, now, what you want to look at is, did we get everybody out? Because if you didn't, you have to build another layer. I'm going to show you that in a minute. And then see this quadratic? You might have to factor again, but we're not going to worry about it right now. So whenever you have higher powers, you want to try to factor further. But we're just going to say that this is simplified. That's a distributive property backwards. Do you guys remember doing this?
Sort of.
Let me show you what happens if you mess up. I'm teaching it. You can recover. So let's say I do a GCF and I take out an x squared and I forget to take out a 2. So I think I'm doing it right. This times what is that? 18x. This times what is that? 14. It's like, oh my gosh, I just realized I forgot to take out a 2. You can build another layer. So 2 times what is 18 now? 9x. 2 times what is 14? 7. And that looks good. So your final answer, you would always multiply these. So all of this is the GCF, the greatest common factor. Now, I'll be honest with you, I normally don't teach this in Algebra 2. So students are supposed to know how to do this already. And so I want you to know that I'm doing this because of the distance learning and everything else. But if you do not know what I'm doing today, you're going to have to spend extra time on it because you're expected to know this. All right, the next factoring method is factoring method 2, and I call it grouping 2 by 2. Now, grouping 2 by 2, you have to have 4 terms. So, for example, I can't make these up off the top of my head. It's too hard, so I have to look them up. I am getting these off your puzzles, but in the class, I usually get the Algebra 1 book. So in Algebra 1, they should have spent all of second semester teaching factoring. Okay, so this is x cubed plus 5x squared minus 7x minus 35. So you always do a GCF first. Can't do a GCF, doesn't work in this one. So now we're going to build two cakes. So what's common in the first cake?
X.
Two of them. There's x squared there and x squared there, right?
Yes.
X squared times what is that? X. X squared times what is that? 5. Now, in order for this to work the way I'm teaching it, these cakes have to match. If the cakes don't match, you're going to have to switch the terms and try again. So if I take out a 7, this is going to be a negative x and the cakes aren't going to match. So what we're going to do is we're going to take out a negative 7. So a negative times a positive x, looks like the cakes are matching, a negative times a positive. So see how the cakes match? So guess what we did? We did the FOIL method backwards. So you're taking these two terms and one cake. And if you multiply this out, you're going to get the polynomial. Watch. First, outer, inner, last, which is the polynomial. Now, the question you should be asking yourself is, why are we doing this? Like what's going on? Okay, let me show you. This right here is a cubic polynomial. And this cubic polynomial looks like a snake. And eventually, you're going to be asked to solve this. And we want to know, where is it crossing the x-axis? Well, we know that it's crossing at -5. That's one of the places. So basically what we're doing is we're breaking down the power so that we can find out where this graph is crossing the x-axis, because those are going to be the solutions. And we're using factoring to do it. Okay, now, factoring is not only used for doing this. So factoring is used in pre-cal and calculus and higher level math classes to simplify. And that's why I'm teaching it to you today. Because a lot of problems don't factor, but you want to be able to factor to simplify. So that would be the answer. Notice we broke the cube down to a square and a single power. When we're factoring, we want to break it all the way down if we can to a single x. Let's do another grouping problem. Remember, you have to do a GCF first, though. Okay, here we go. Can't do a GCF. It looked like we could take out a 2, but it's messing up the problem. So we're going to make 2 cakes. We do have 4 terms. What can you take out of the first cake?
You can take out 2x squared.
Yep. So 2x squared times what is that? 2x. 2x times what is that? 3. What can you take out of the next cake? Would be a 3. So 3 times what is that? 2x. It looks like the cakes are matching. 3 times what is 9? And they do match, which means we did the FOIL method backwards. So the answer would be 2x squared plus 3 times 2x plus 3. 2x 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 plus 3 times You guys okay with that? Can you guys give me some feedback? Did the teachers teach this, or you never seen it before, or?
I've never
Seen it before.
Yeah, same.
Okay, do you understand what I did though?
Yeah.
All right, the third, fourth, and fifth method on this sheet. And if I were you, I would print out this sheet under materials in Google Classroom. These are the factory methods, and you should have them right in your face at all times. Difference of squares is two terms, and this is the easiest one. And that's why it's a special case. So you try to do a GCF.
Miss Bird, can you move your camera a little bit, please? Thank you.
You try to do a GCF, you try to do grouping, then you'd look at, see if this is the difference of two squares. Well, let's check it. Difference means minus. Is it the difference of two squares? Because if it is, we're going to write it as the product of a sum and a difference. So is x squared a square? Yes, it is. Is 4 a square? Yes, it is. So our answer is x plus 2 times x minus 2. Now, students always ask me, is it always going to work like that? Yes, it's always going to work like that. In fact, this one's going to be so easy for you, you're just going to look at it and do it. So watch. X squared minus 9. Wouldn't that be x plus 3 times x minus 3? X squared minus 25. Wouldn't that be x plus 5 times x minus 5? You guys with me or no?
Yeah, this one's easy.
And the teachers probably taught you this one, right? No?
I don't
Yeah.
remember seeing it.
Okay. Let's do a harder one. Watch this. Now, you can't do a GCF, but this does look like the difference of two squares. So let's test it out. Is it the difference of two squares? If it is, we can write it as the product of a sum and a difference. So wouldn't this be 2x times 2x? And wouldn't this be 5 times 5y times 5y? So
Yeah.
wouldn't the answer be 2x plus 5y times 2x minus 5y?
Yes.
By the way, this is the thing that I teach the best of anything I teach, because when I was in high school, the teachers just wanted us to guess. There were no methods. We just had to guess. And I had to go to my aunt's house every night to try to get myself straightened out because I did not understand it. So when I started teaching, I made a vow to myself that I was gonna learn, go through all the methods. I was gonna watch a bunch of different conferences, and I was gonna find out how to teach this best. And so what this is a conglomeration of a bunch of different methods, including my own. And this is the one thing that I teach best. So this is a special case, and it's because it's quick and easy. So we're gonna like the special cases. And if you wanna make a note of this, 3, 4, and 5, when I go over 3, 4, and 5, those are the special cases. So let's look at method number 4. Method number 4 is not used a lot. It's a perfect square trinomial. And this guy needs 3 terms. In fact, methods 4, 5, and 6 are all 3 terms. Now, this method is only used with really big numbers. So let me give you some big numbers here so that you appreciate this one. So this is a nasty problem. And what you want to notice is that this is a perfect square and this positive is a perfect square. So what we're going to do is we're going to test to see if it's a perfect square trinomial. So off to the side, we're going to do a 3-step test. So here are the steps. Is the first one a square? Is the third one a square? And then you're going to put in 6x and 4 and multiply, and we get 48x, which matches the middle term almost. So if it differs by a negative, the middle term, it's the square of a difference. If it matches it perfectly, it's the square of a sum. So all you do is put the 6x and the 4 in there. If this is a minus, it's not a perfect square trinomial. So you look at this problem and you go, okay, the factors of 9 are 3 times 3, can't do a GCF. So what you want to notice is that that looks like a perfect square and that looks like a perfect square. So we want to see if it's a perfect square trinomial. Now, if it fails at any part of this test, it's not a perfect square trinomial. So this would be 3x times 3x, and 8 times 8 is 64. Put the 3x and the 8 in there, and you get 48x, and it matches it perfectly. So if it matches the middle term, it's the square of a sum. And the answer would be 3x plus 8 on b squared.
It's Birch. You said if it matches the middle term, then it is a what?
Okay, see how this 48 matches that 48? It's the square of a sum plus. If this is a negative and this is a positive, if it just differs by a negative, it's the square of a difference. And come on, let's face it. Look at this, you guys. Watch. I'm going to erase this. Let's say you're doing the problems, and you look at this and go, that looks like a perfect square trinomial. Can't you just guess? Like, couldn't you just do this? That's probably 6x. That's probably 4. And that's a negative. Couldn't you just check it and see? 6x minus 4 times 6x minus 4, isn't that 36x squared minus 10x? Sorry, minus 24x minus 24x plus 16. Isn't that 36x squared minus 48x plus 16? Yeah. So that's the perfect square trinomial. I mean, you could just guess, but make sure you can do it right. What square is that? 6x. What square is that? 4. What do you think goes in the middle if that's a negative, a minus? I wanted to show you a systematic way of doing it though, by that 3-step test. But if you want to just guess and check, that's fine. What I normally do. Okay, so that's factoring method 4, the perfect square trinomial. Okay, the next one is also a special case. It's factoring method 5, and it's called the form x squared plus bx plus c. It does require 3 terms. And the reason why this is a special case is because that's a 1. So for example, if you had x squared plus 5x plus 6, for those of you who have seen this before, you could just guess what multiplies to give 6 and adds to give 5, a 3 and a 2. I'll show you a way. Hold on. What if you had x squared plus 4x minus 32? You could just guess. 32 is 8 and 4. The 8 has to be positive. That has to be negative to multiply to get a negative and add to give a FOIL of 4x in the middle. All right, now let's say that you're totally confused and you don't get what I'm doing. You could put a 1 here. And you want to multiply to get a 6. And you want to add to get a middle term. So you start guessing. 1 times 6, 2 times 3. 3 times 2 means you're repeating. So isn't 2 times 3 6 and 2 plus 3 5? So can't you just write the answer? X plus 2 times x plus 3 and be done with it? What about this one? Don't you want to multiply to get a negative 32? Because isn't that negative 32 times 1? So you want to multiply to get a negative 32, and you want to add to get 4. So you start guessing. 1 times 32, 2 times 16, 3 doesn't work, 4 times 8, 5 doesn't work, 6 doesn't work, 7, 8 times 4, you repeat. Do any of these? Well, this has to multiply to get a negative. So that means one of these numbers has to be negative. And isn't negative 4 plus 8 the middle term? There's only one that's going to work. So wouldn't it just be x plus 8 times x minus 4? Do you want to do another one of these or no?
Yeah.
Okay, you try to do a GCF, can't do it. Grouping, no. Difference of squares, no. Perfect square trinomial, no. It's factoring method 5 because of that 1. So negative 6 times 1 is negative 6. And you want to multiply to get a negative 6 and add to give a negative 1. So you get 1 times 6, 2 times 3, 3 times 2. It wraps, stop. You have to multiply to get a negative and add to get a negative, which means the bigger number has to be negative. So isn't it 2 times negative 3 is negative 6 and 2 minus 3 is negative 1? So write the answer. Can I go on?
Yes.
Please tell me the teachers taught this one, right?
They didn't explain it like you are right now. I think
Okay.
we had like 2 methods and then
Yeah. The teachers, when they introduce this, sometimes they do the X method and sometimes they do a box method. So that's perfectly great and everything, but at this point in Algebra 2, you want to do it the way I'm doing it because we don't have time for the X's and the boxes. And you're not going to like it. So yeah, so it's good that they introduced it like that. But you're right, I am introducing it another way. Okay. The next one is the worst. And it's not that it's hard. I call it stupid factor method 6. And what it is, it's the form ax squared plus bx plus c. And like I said, it's not hard. But what you want to notice is this isn't a 1. This is also 3 terms. That should be blue. And like I said, it's not hard, it's just a pain. So sure enough, you go through your list. Can you do a GCF? No. Can you do grouping 2 by 2? Is it the difference of squares? No. Is it a perfect square trinomial? That's a negative. Is it factoring method 5? No, it's stupid factoring method 6. So look what you have to do. You have to multiply these to get a negative 30. And you have to add to get a negative 1. So you have 1 times 30, 2 times 15, 3 times 10, 4 doesn't work, 5 times 6, 6 times 5, stop. Since you have to add to get a negative, the bigger number has to be negative. So wouldn't it be 5 minus 6? Five times negative 6 is negative 30, and 5 minus 6 is negative 1. Well, guess what? You can't write the answer. Factoring method 5, you can write the answer, but you can't write the answer. Look what you have to do. Watch. You have to bring this guy down. You have to bring this guy down. And you have to put the factors in with the variable. So I'm going to put negative 6y with the 2 and 5y with the 15. So see how that represents the middle term, negative 1y? And now guess what we have to do? We have to do grouping 2 by 2. So the greatest common factor here is 2y times what is that y? 2y times what is that? Negative 3. I'm going to take out a 5. 5 times what is that? Y. 5 times what is that? Negative 3. The cakes match. So our answer is 2y plus 5 times y minus 3. And so it's not that it was hard, but it's just a pain. I'm almost out of time, so I'm not going to get to the sum and difference of cubes, but I'll do one more of these. You try to do a GCF, can't. It's not grouping 2 by 2. It's not the difference squares. It's not a perfect square trinomial. It's factoring method 6. And so you want to multiply to get 36. And you want to add to get 13. So this would be 1 times 36, 2 times 18, 3 times 12, 4 times 9. And I think it's 4 times 9. Because 4 plus 9 is the middle term. So once again, you have to bring the 6y squared down. You have to bring the 6 down and put the factors in with the variable. So I'm going to put plus 4y with the 6. It doesn't matter where you put it. Put it with the nice one. Put 9y with that 6. And do grouping. So like you would never want to put a 5 with a 3 if you can avoid it. You want to put a 5 with a 10 or 15. You want to put a 2 with an 8, you know, an even number. So, because you have to get those cakes to match. So on this one, you can take out a 2y times what is that? 3y. 2y times what is that? 2. On this one, you can take out a 3. So 3 times what is that? 3y. 3 times what is that? And the cakes match. So the answer would be 2y plus 3 times 3y plus 2. So it all fits together like a puzzle. Okay, now, like I said, I'm going to stop there today. And this right here, the assignment is in Google Classroom. It is the factoring puzzles. You should be able to do all the puzzles except for number 7, which is the sum and difference of cubes, which is actually Algebra 2. So everything I did today was Algebra 1. The sum and difference of cubes is Algebra 2. All right, does anybody want to ask me any questions about this before I erase it?
I don't think so.
Okay. So you think you had this, but you had it taught a different way?
I think they didn't, because they gave it to us in separate lessons from what I remember. I have old notebooks I could check, but I remember like scientific notation, the FOIL method, but I don't think we went into them like, I don't know. It just does, I don't remember it going so, I don't know, but I know we were introducing them.
Okay, thank you. Okay, well, we have like 2 minutes. Like I said, I hope these puzzles are fun. I think the repetitiveness is going to help because right now in pre-cal, they're having to factor 4 to 6 times in one problem. So you have to know how to factor. If you notice, I really didn't look up anything when I was teaching because I know it like breathing. You really have to be really good at factoring. It will make your life a lot easier in this class and in future classes. So I'm hoping these puzzles will be fun, but also really help to make sure you do this assignment. If you do any assignment this year, make sure you do this one. And the next time I see you, I'll teach factory method 7. Sound good? All right, guys, I miss you. I can't wait to meet you in person. Yeah, it's just killing me not to see you guys. So have a good rest of the day, okay? Have a good rest of the day.
Have a nice
Okay,
day.
bye, guys. Bye, guys. I'll see you soon.